What's up, everybody? It is Mr. Privet back again with some calculus, looking at another FRQ review, doing the 2021 AP exam, question number 5. It's a solid FRQ looking like it. We got some differentials, tangents, minimums, maximums. So this should be a really interesting question. I'm excited about it. But thank you guys so much for just being a part of these videos, watching. I appreciate the support. I love making these videos, and I hope that you guys are really growing in your knowledge of calculus because of it. Hopefully also just, getting some renewed love for these concepts as well. But let's try this out. Let's read question 5. It says, consider the function y equals f of x, whose curve is given by the equation 2y squared minus 6 equals y sine x, for y is greater than 0. Part A says, show that dy dx equals y cosine x divided by 4y minus sine x. Okay, so we have an equation, 2y squared minus 6 equals y sine x. And it's asking me to show that my derivative of y with respect to x is, this function. And I can do that by taking an implicit derivative of my equation. So when I take the derivative of 2y squared, for instance, I will get just the normal derivative, 4y, but then I will get a dy dx, or as I like to write it, y prime, right? So that's the derivative of 2y squared. Minus 6, taking the derivative of that, it's just 0. Now y sine x, I'm going to have to use product rule, because this is a function times a function. So I'll do first term times the derivative of the second term, just the cosine of x, plus the derivative of the first term, which is y prime, times the second term, which is sine x. And now to solve for dy dx, I just need to isolate y prime. So I'll subtract over this y prime sine x. I'll get 4y, y prime, minus y prime sine of x equals y cosine x. I factor out a y prime. I get 4y minus sine x equals y cosine x. And I divide it out as the final step, y cosine of x divided by 4y minus sine x. And I factored it out just so I could isolate it right here at the very end. Now, hopefully I would not be stupid enough, that was funny, but I wouldn't be stupid enough to get to my y prime, circle my answer nice and big, if it wasn't what they gave us in part A. Like if my answer did not match what the AP gave us, I should not circle that. I should cross out all of my work and do it again, right? But thankfully my answers do match, so we are totally comfortable and confident with our answer for part A. So, not too bad. I think that was very reasonable. But we will move on to part B. Generally, questions like that are only worth 1 point. Let's see, I can check and see how much that one was worth. Ooh, that one was actually worth 2 points. 2 points for getting an answer they already gave us. How about that? It's a good feeling, right? Let's look at part B now, though. I'm expecting it'll get a little tougher, right? Let's try it out. It says write an equation for the line tangent to the curve at the point 0, comma root 3. Now there are two things that we need for a tangent line, right? I need my point, but I also need my slope, right? And my slope can be represented by this differential, dy dx. That is the slope of the tangent line at a point on the curve. So if I plug in x equals 0, y equals root 3, that should give me the slope of the tangent line. So y is root 3, this will be root 3 times the cosine of 0 divided by 4 root 3 minus the sine of 0. The cosine of 0 is equal to 1, so that numerator is just root 3. The sine of 0 is just 0, so I get root 3 divided by 4 root 3, which is 1/4. And that is our slope. Those are the only two things that we need for a tangent line, right? So I just set up my equation, y minus y1 is equal to my slope times x minus x1, which is just 0. So I could write it like that. Y minus root 3 equals 1/4 times x, which is our equation of the tangent line. So that is all we got for part B, only worth 1 point. So very simple question for a part B, not too bad at all. Just find that slope, right, using the differential. But here we go, we're chugging along. I like this. Let's look at part C. Part C says for x's between 0 and pi and y is greater than 0, which it told us at the beginning of the question, find the coordinates of the point where the line tangent to the curve is horizontal. Okay, so if we have a horizontal tangent line, what does that mean? Well, it means our derivative, or dy dx, equals 0 because it's horizontal, right? Horizontal line has a slope of 0. So, I've got this formula for my differential. Dy dx equals y cosine of x divided by 4y minus sine x. That has to equal 0. Now, my denominator doesn't really matter for this. All we take from it is y cosine of x has to equal 0, right? Because that's my numerator. Now, can y equal 0? No, they tell us that y is greater than 0. So therefore, the cosine of x has to equal 0, and x is between 0 and pi. Now, if we think about the unit circle, cosine is like our x value, right? And at the top of our unit circle, when we are at the angle of pi over 2, my x-coordinate is equal to 0. So that is my x value, x equals pi over 2. But it doesn't just ask for the x value, right? It asks for the coordinates. So I have my x. How do I solve for my y? Well, thankfully, they give us the equation of the curve, right? 2y squared minus 6 equals y sine x. And I have my x value, so I'll just plug it in. 2y squared minus 6 equals y times the sine pi over 2. We saw it earlier, but the sine of pi over 2 was equal to 1. So 2y squared minus 6 equals y times 1, or just y. So 2y squared minus y minus 6 equals 0. I got a factor. I feel like all of us are bad at factoring, but I'm great at it, let me tell you. So I'll get 2y plus 3 times y minus 2. That's my factoring for this quadratic, right? So my solutions are y equals negative 3 halves and y equals 2. But what do we know? Y is greater than 0. So their y value is y equals 2. So my coordinates for this point would be pi over 2, comma 2. And that would be our final answer for part C. So this was an interesting one, right? Understanding that for a horizontal tangent, our differential is 0. The only way this is true is if cosine equals 0, solving for x, plugging it back in, solving for y to get the coordinates. Solid question, right? It was worth 3 points. And I think that's a very reasonable 3-point question. We should be pretty capable of getting this one. I know some people might not be quite as unit circle confident, so maybe they're messing up this part. Who knows? But overall, very reasonable question. But we will move on to the final part, part D. See, all of this has been so reasonable that I always get scared going to part D's that we're just about to get absolutely massacred, right? We'll check it out. So it says, determine whether f has a relative minimum, a relative maximum, or neither at the point found in part C. So the point that we found was pi over 2, comma, 2. That was our point. And they're asking us, is it a relative minimum, a relative maximum, or neither? Okay. Well, we found that at this point, right, dy dx equaled 0, right? Because it was a horizontal tangent, right? All right, now, horizontal tangent. But we know that for a relative minimum, right, that's where my derivative goes from negative to positive. A relative maximum is where it goes from positive to negative. And neither would be something where it just is positive on both sides, negative on both sides. So I need to figure out, like, is this a minimum or maximum? And we can do this by looking at my derivative. dy dx equals y times the cosine of x divided by 4y minus sine x. So let's think about it. What I'm going to do is I'm going to set up kind of two separate number lines, right? And I'm going to look at pi over 2 and 2 as kind of these separate critical values and see what happens to the value of these functions when I'm close to it, right? So, right, I'm going to look kind of at these two sides. For x, I'm going to look at both sides of pi over 2. For y, I can look on both sides of 2. So I'll just kind of put this as x, this is y. So let's look at the denominator first, okay? Now, for y, right, y is going to be around 2. For y, it's going to be close to 8. If it's slightly less than 2, for y will be slightly less than 8. It's greater than 2, it'll be slightly greater than 8. So this is positive on both sides. Now the sine of pi over 2 is equal to 1. If I plug in a number slightly greater than pi over 2, I'll get a number slightly less than 1. And same thing on the other side. I'll get a number slightly less than 1. So is 4y minus sine x changing signs? I would say no. 4y minus sine x is always positive, right? This is always a positive value. Now, my numerator might be a little bit different, right? We know that y is always going to be positive because it's around y equals 2, so we're not really worried about that. But we do need to check out cosine of x on either side of pi over 2, right? We're going from positive to negative, negative to positive. What's going on? So if I plugged in a number less than pi over 2, like pi over 4, my cosine of pi over 4 is root 2 over 2. So this is a positive value. So positive y times a positive cosine x, I get a positive value for the numerator. Now if I plugged in a number greater than pi over 2, well, y is still positive, but the cosine of like 3 pi over 4 is negative root 2 over 2. So my y cosine of x would now become negative. So as my x goes from, the left side of pi over 2 to the right side, I'm going from positive to negative, while my denominator is always staying positive. So my entire derivative is going from positive to negative. So therefore, this is a relative maximum. And this would be our correct answer to part D. Now, Let me tell you, there are kind of multiple ways to approach this. I find this to be the easiest way to approach it, which might feel crazy. You might be like, Mr. Prevet, what's going on? There's a lot of concepts going on in this. This like double number line thing. What's up with that? Why are we even doing that? What's going on? Right? But the other way to approach this is by using the second test for extrema, or oh goodness, I'm forgetting what the second derivative test, right? And what that says is that if our second derivative of a function is greater than 0 at a point where we have a, you know, critical value, then that is a relative minimum. Sorry, not maximum. And if f double prime is less than 0, we have a relative maximum. And if our second derivative equals 0, then we have neither. That's our second derivative test, right? This is where first derivative is 0 or undefined. Now, this is really easy when we just have normal functions, right? This is not very easy for this function because we would have to take the derivative of this, which is disgusting. We would have to do quotient rule, taking the derivative of this 4y, right? It would be 4y prime, right? This y cosine x would be y prime cosine x minus y sine x. It would be an absolute mess. We'd have to go back in and calculate dy dx, like so many steps. So this method would be very algebraic, but it would take a lot of time. Figuring this out conceptually, I feel like is much quicker. It's cleaner. You're less likely to make a mistake. Maybe it takes some higher level of understanding. I really don't think so though, because I've also never seen these questions come up where it is neither. Normally it's always a minimum or maximum, and one of these two things is always going to stay the same sign. One of them is going to change. So the AP isn't going to try and confuse you too badly on it. But definitely a really challenging question. Part D is tough. This is a really challenging one. There's a reason that, it's worth those 3 points. But that is all of question number 5, a tough one. Differentials, kind of taking a different spin on it in part D, which I like. But yeah, a really cool question. I enjoyed this a lot. I hope that this was really helpful for you guys and just, maybe gave you that 1% better in calculus, because I really want y'all to succeed on that AP exam. But until next time, it was great hanging with you. I'll see you on the next video.